Welcome to the non-clustered indexes module. Now, up until now, I've been having you just work with the clustered index, the white pages, the first 4 pages of the PDF. Now, I'm going to be giving you an index. See, I'm constantly querying by the same thing, last access date. So if I know that my application is always querying by that, why don't I create a copy of the table that's sorted in the order that I want and has just the fields that I want? This is the black page, the 5th page, page 5 of your PDF. Now, I created this index with the statement that you've got here on the screen, create index IX last access date. I like to name my indexes with the fields that they're on. So last access date ID in this case, those 2 fields that I've got there. I don't like including a table name, it's just extra baggage when I'm looking down through the list of indexes. So as you look at that closer, I'll throw it up on the screen there. As you look at it closer, one of the things that you're going to notice is that this is a lot more dense. I'm able to put more records on each 8K page because I'm only setting in 2 fields here, last access date and ID. So there's 4 columns of users here. I can store 4 times as many people on every 8K page. But of course, the flip side of that is I've only got 2 fields here. I don't have all of the fields that I had in my clustered index. The next thing that you're going to notice is that you now have 2 copies of the table. Every time you do an insert, update, or delete, you're going to have to do it in 2 places. Well, not exactly. If you updated, say, display name isn't on the black page, so you wouldn't have to touch it. You'd only have to grab one particular page here, the clustered index. So I might even have to make different indexing decisions based on how frequently the fields get updated. If a field gets updated all the time, maybe it's not the best field to put inside of an index because now I have to update it in 2 different places. Of course, in real life, I probably wouldn't access a field like last access date, which is constantly changing every time the user logs into the site. But I digress. So let's give you one of your queries again. We're going to get select ID from users where the last access date is greater than 7/1 of 2010, order by the last access date. Now you have 2 different copies of the table that you get to choose from here. And it's pretty much a no-brainer. You're going to want to grab the black page, seek directly to the row that matters, and start reading that data out in order. That's exactly what SQL Server's execution plan looks like. Now we're down to 1 operation here, an index seek. Notice that SQL Server explains the index name here, IX last access date and ID. It's one of the reasons why I like having the field names right there on the index when I'm looking at execution plans. So how much does this really save us? We're going to have to compare the old execution plan and the new one. The old one is up at the top. Notice that we had several operators in there. We started with a clustered index scan, then we did a sort, then we recombined our stuff from parallelism. And the estimated subtree cost on that, 150, whereas down at the bottom, when we had our non-clustered index, just 6.2, or roughly 25 times faster. It's hard to make your storage 25 times faster. It's hard to make your memory 25 times bigger. Now, it's hard to make your CPUs 50 times faster. But these are the kinds of numbers that you can usually see when you're doing index tuning, and it's even better than that. If we look at our friend setStatistics.io that shows us how many page reads we did, the first one, when I just scanned the clustered index, we did 31,936 page reads. With the index, we just read 4 pages. Dun, dun, dun! Thousands of times better, almost 10,000 times better. Now, this is a beautiful example of what we call a covering index. Now, the term covering doesn't mean a special kind of index. It always means something in combination with a query. That query has all of the fields it needs covered by that index. But that's not necessarily the case if we change our query. Now I've added 2 more fields. Select ID, display name, and age. Now given the two copies of the table that you have, how do you execute this? Now, I bet what you thought of is, I'm going to go seek to one specific area on this non-clustered index. I'm going to read them out in order, and I'm going to make a list. Remember, I want you to think of yourself as a human being here. I'm not very bright. I can't remember all of the last access dates and IDs that I'm going to need to go look up over here. I'm going to have to go write them down somewhere in a scratch pad. Maybe that area is memory. Maybe it's SQL Server's TempDB. We'll get more into that in a later module, figuring out which one it's going to be. And then I'm going to turn around and look up that data on my clustered index. It's exactly what SQL Server's execution plan looks like. And remember, we read right to left, top to bottom. So the first thing that SQL Server does is that index seek on our non-clustered index. Goes and looks up the rows that it needs, makes a list in its nested loops there to go look up the remaining rows down at the bottom. This is an interesting problem here when we're looking at execution plans. If you hover your mouse over the key lookup, notice that right down there at the bottom there, we've got seek predicates. This is what we're looking up. Now, my non-clustered index included both last access date and ID. The ID is so that I can look back up over on the clustered index. I have to be able to join these two things together. I didn't have to tell SQL Server I want this index on both last access date and ID. SQL Server will always include the clustering key so that it can look back and forth between the different copies of the table. So that seek predicate says go look up by ID, and then look right above that. It has an output list. This is the number of fields that I needed off of this clustered index that were not in the non-clustered index. This is a classic index tuning problem. Whenever you see these two operations stacked right on top of each other, I want to hover my mouse over the clustered index, the key lookup part, and see what extra fields did I need. Because if I just added those to this index, I could make that two-part process simply go away. Now, that's not always a good idea, but let's look at whether or not it's a good idea in our case by giving you another index. These are pages 6 and 7 of your PDF, the gray pages. The gray pages are a slightly wider index. They still start with the same two fields, last access date and ID. But then I've added two more fields, display name and age, on there. Now, I could have created that with either of the two create index statements that you see up at the top here. I could either create the index on all four fields explicitly, or I could just include display name and age. This is a new feature in SQL Server 2005. I'm new, it's like 10 years on now. Not everybody uses it because if you had to build an application a long time ago, it's legacy or it has to support multiple databases. Not all databases support the include statement. What this does is it just tacks those extra fields into the index leaf pages, but doesn't sort by them. So for example, if, let's just pick a user at random here, where's ID number? Who knows? I'll just pick any old number you're going to have to find in yourself. Let's say the very first one on there, community. Let's say that we decide to change that to communism. I don't know, man, see, this is why I get bad letters. As soon as I start just ad-libbing, immediately bad things happen. So let's say that we change community to communism, which might be sorted a little bit differently. Do we actually need to move him on this page or to another place? It's kind of a trick question. If his last access date didn't change, then I wouldn't need to move him because there's not a lot of people sharing that exact same last access date. So it's kind of a hit or miss as to whether or not it really affects you or whether or not includes really make anything faster. But the thing I want you to take away is that they are not free. This index is exactly twice as big as the black index. Notice we have two pages here to include the exact same number of rows because the gray index is twice as wide. it needs more space to store display name and age. The wider your indexes are, the more space they're going to take in memory and on disk. Another thing that you're going to notice now is that I now have 3 separate copies of the table. Whenever I go to do inserts, updates, and deletes, I'm going to have a lot of work to do. So let's give you that query again. Same exact query. ID, display name, and age. How are you going to execute this one? Now you're back down to just one operation. You can grab the gray index, seek directly to the rows that you want, and read them out in order because it has all of the fields that you need. There's something a little suspicious about this query, though. If I look at this execution plan, that's a really big arrow. That doesn't seem like index seek makes it sound like it's hardly any work. What happens if I hover my mouse over that index seek and I look at the estimated and actual number of rows? 2.2 million rows are coming out of this. Well, that's kind of odd. When you think seek, you think, oh, I'm going to go directly to one point and just read a few things out and bail. What happens if I change that date? Right now it's 7/1 of 2010. What happens if I change it to 1/1/1800? That arrow size is exactly the same because it's a ton of data. It's almost all of our data because, after all, everybody's used Stack Overflow since 7/1 of 2010. That's a really old date, and everybody's been logging in since then. The thing I want you to take away is when you look at an execution plan and you see index seek, that does not equate to awesome. You might be reading a whole lot of data, or you might be hitting a just simply really long range. Don't think the seek is immediately always going to be the best performance, or that it's not really the same thing as a scan. Now, we're running into a problem here because I have a whole lot of data pages now for exactly the same people. I have my black index, my gray index, my white index. And as I go through and I do these inserts, updates, and deletes, this means I've got a larger database, and every maintenance job that I have will take longer to run. Backups, DBCCs, restores, updating statistics, index defrags, index rebuilds, all of that is multiplied now because I've got more copies of my pages. And it's even funny that building query plans can take longer because SQL Server has to think harder across all of our tables and all the different indexes that we have. What's the most efficient way to get it done? SQL Server has to build these plans in a matter of milliseconds to get your query out the door. SQL Server doesn't stop and think for minutes trying to figure out your execution plan. And even when I'm dealing with high availability and disaster recovery, as I change more pages, that means I have to push more data out via log shipping, replication, always-on availability groups, database mirroring, all that stuff. So when I'm trying to make design decisions, SQL Server includes something called Dynamic Management Views, DMVs, and Dynamic Management Functions, DMFs. These are system tables or system views that we can query to see metrics about how our SQL Server is doing. Often these things are reset whenever SQL Server restarts. You'll notice here on the screen I'm querying DMDB index usage stats, where SQL tells me for every single index how many seeks I've done, how many scans I've done, lookups, and updates, which is times that the data has been inserted, updated, or deleted. So obviously I want my indexes to have as much bang for the buck as possible. I want to use them as much as possible and not update them if I can avoid it. Now, because this data resets every time SQL Server restarts, I want you to think of yourself as a SQL Server and we just rebooted you. I just hit your reset switch, your magic button. Oh, the jokes I could make there. And whenever you do that, as soon as I run your index usage statement query again, you're going to have no results returned. This is after I restarted my real SQL Server. Now I have no data in there, and let's start running queries and see which indexes get used. You as a human being, you, the SQL Server engine, run the wide query, the one that wants ID, display name, and age. Which index are you going to use out of all of these? How are you going to accomplish it? Well, if you're like me and you're lazy, you're going to take the gray index, which is the narrowest copy of the table that has all of the data that we need. I can seek right to the rows that I want and read them out in order. Now, at this point, that index, or at least the pages I needed from it, are cached up in memory. I don't need to read them off of disk. That's a win, and I've used this index once. I'm going to mark this down once in my DMVs. Now, a user comes along and runs the narrower query, the one that only needs ID. Which index am I going to use? Now, I bet you're like me. You think that I'm going to drop these off my head, and I do. You think that because this one is in cache, we're going to use it. That's not how SQL Server works. SQL Server always wants the narrowest copy of the table that satisfies the data that we're looking for and is sorted in the correct order. Plus, remember, SQL Server is going to build these execution plans and keep them in cache as long as it can, and the data that's in RAM will change all the time throughout the life of our SQL Server being up. So even though I just read from the other one, if I go and look at my DMV queries, or if I look at my execution plans, the two different indexes get used. In the top one is my wide index, in the bottom one is my black index. It's narrower there. And if I query SQL Server's index usage DMVs, they're both getting used. Notice rows 2 and 3. Last access date ID, display name, and age got used once, and last access date and ID got used once. Both of them get used, even though they're kind of duplicates, and I really don't want to use both of them. So in order to explain how I do performance tuning, I want to introduce you to one of my favorite legends of Formula One racing, Colin Chapman. Colin Chapman started Lotus Cars. He was a visionary. He was one of the pioneers in aerodynamics, strapping a wing to the back of his cars. As you can see, this is one of his cars there from Team Lotus. The engine is actually part of the car. Now, I know you think of that as all cars. Well, the engine's sitting in there. No. The driver's seat, the whole frame is bolted to the engine. The engine is an essential part of the car. If you took the engine out, the whole car would fall in half because he was trying to save as much weight as he possibly could. Colin was notorious for saying if a race car doesn't finish first, it's useless. Race cars that can't win are dead to me. Well, he didn't use the words dead to me. That came a little later after Colin had passed away. But the point being that Colin would strip everything he possibly could out of his cars. Now, even when he went to go make consumer cars, this is an actual car that Colin sold to the public, the Lotus 7. And this thing is as bare bones as you can get. Forget air conditioning, it didn't have a top. You can, when you're driving a Lotus 7, you can reach your arm out over the door sill and you can touch the ground. That's how small and light these cars are. Notice there's not even roll-up windows or anything like that. And the woman in this picture is having to rest her arm outside of the car because that's how tiny the car is. Colin had a quote that he said, "Simplicate and then add lightness." Strip your car down to the barest, simplest possible details, and then even keep stripping parts out to make it as simple as possible. That is what I want to think about doing when I'm dealing with index tuning. I want to ask myself, what would Colin Chapman do? Colin would look at all of this excess weight and say, you know what, I need to get rid of one of these X's, or these indexes, which I need to get rid of all of my X's too. Don't put that on. Don't say that in public. You know it's going to go in here because I'm going to forget about that part. Colin would say, I want to get rid of the black index because it's narrower and it's a subset of the gray index, which has more fields and will satisfy exactly the same queries because they both start in the same order. Now, in a later module, we're going to talk about why key order is so important in indexes. You can't have indexes in different order and think that they're duplicates. So to recap everything that we talked about here in this module, first off, narrower indexes like the black one are very compact and don't take up much space, but unfortunately, they don't satisfy many queries. whereas slightly wider ones like the gray index satisfy more queries because they cover more queries. There's no right answer that works everywhere as to how many fields you should have on an index or how many indexes you should have. This is what we like to call job security, and that's why you're here. You get to make these design decisions for every single database that you have. The more indexes that you add, the faster your queries might go, but not the insert, update, delete queries, and not your backups, index rebuilds, update statistics, all of that stuff. The only thing that indexes make faster is selects, and they slow everything else down. Well, that's not exactly true either. In the deletes module, we'll talk about how indexes can make even deletes and updates go faster as well when they're done correctly. We also talked about how seek does not automatically equate to awesome. You could still be reading large amounts of data out even though it's a seek. We talked about how the SQL Server index DMVs don't really tell the whole story. They will say that all of your indexes are really getting used, but that doesn't mean you couldn't drop some of them and go faster. And think like what Colin Chapman would do. He would go look out at all of the data that's out there and then use his own noodle in order to figure out which indexes he needed to drop. So that's our non-clustered index tuning module. Now we'll discover what's going on in the next module.